All right, let me start. Hello, everybody. My name is Łukasz Banachowicz. I'm a sales director at Unbox Robotics, responsible for the EMEA region. I've been working in the warehouse automation space with multiple solution suppliers for the past decade. But today I would like to talk about a new approach towards sortation solutions based on what we call the world's first vertical mobile sortation system. So throughout this presentation, I'll bring to your attention a little bit more about the system itself, also the company itself, but also the challenges we see on the market. So let me start with the challenges that kind of defined our path and defined the way the solution looks like right now. So first of all, we see that current operations are very often based on fixed automation, right? And the problems we see with that is that very often it requires a big number of operators working in the process. So whenever your operation is highly reliant on manual workforce, that's where you lose a certain level of predictability in the system, a certain level of flexibility, and also we know it's significantly driving the cost of operation up. Right? At the same time, whenever we are talking about fixed automation, and by fixed automation, I'm mainly thinking about solutions based on conveying systems or cross-belt sorters, steel tray sorters. They very often require multiple touch points from the operation, right? So the sortation process is then split into several stages, and therefore the overall operation gets longer and costlier. At the same time, the installation time of such systems is relatively long. They consume much more space when they should. They are difficult to scale and they are not flexible. And in the current very dynamic logistics world, it's becoming difficult to accept. The maintenance can be costly, and the overall integration with the existing infrastructure can be difficult. So these are the challenges we have identified on the market, and these are the challenges we try to help with through our solution. So very early in our journey, we have asked ourselves the question, what if the future of automation isn't built on fixed systems, but on flexibility when it's needed most? So that's where the idea for Unbox Robotics has popped up, and that's the solution we have created. Let me start with a brief video just to give you a better understanding of what I'm talking about here.
Every once in a while comes along a solution that empowers you to rapidly adapt to a transforming world. A revolutionary solution created to enhance your life with automation in new ways. A solution powered by swarm intelligence and machine learning, helping create an environment of speed, efficiency, and collaboration. A solution that redefines the concept of space by unlocking the potential of order fulfillment in all dimensions, rapidly scaling to fit ever-growing demand. A piece of the future designed for the world of today.
Right. So that's how the solution looks like. As you see, this is a sortation system based on mobile robots that, apart from moving horizontally, they have the ability to also move vertically. So that allows us to sort large volumes of items, of parcels, into a big number of destinations in a relatively small space. So now, who is Unbox Robotics? Unbox Robotics is an Indian company founded in 2019 by 3 engineers. Shahid, one of our founders, is a robotics scientist, you could say. He's a serial entrepreneur. And Rohit and Pramod, they have been working at, on the other side of the table, you could say. They were working at Flipkart, which is India's biggest e-commerce company. They are currently owned by Walmart. So they have been, at the time before they founded the company, they have been responsible for implementing India's first robotic system for sortation. And during the process of evaluation of all the solutions available on the market, they have realized that there are certain gaps. The solutions that were available at the time didn't meet all the expectations of the process. So they started to to think about it. And as a result, they created Unbox in 2019. In 2022, we had our first installation. And since then, we have grown to a team of more than 150 people. We have more than 20 live deployments globally. You can see some of our references on this slide. More than 500 robots deployed with the sorting capacity of around 10 million units every month. And recently we have gone through a Series B funding, which values our company at more than $100 million. Okay. As I mentioned, we are present globally. Our HQ is still in India, and it will remain in India for sure. But let's say our presence now especially extended to Europe, but also to US. In Europe, we have most of our installations. As you see, there's a site here in Netherlands, not so far from here in Breda. We have a site in Belgium, Spain, Italy, Turkey, and there are multiple sites that are coming this year. On top of that, we are supported by a network of local partners, so we believe that we need to stick close to our customers, and therefore those partnerships allow us to scale faster, but also be able to support our clients whenever they need it. Now, no matter what type of facility you run, whether it's an fulfillment center, whether it's a sortation center, last mile hub, or a return center, and no matter what type of, let's say, industry vertical you are in, meaning in the logistics space, you probably feel the same pressure, the same challenges, right? Everybody needs to sort. But the thing is that the logistics space is becoming more and more dynamic, right? We have more and more SKUs. The product variety is increasing. We have more peaks. We are not talking about Black Friday anymore. We have peaks throughout the year multiple times. And you need the operation that will be able to adjust to the ever-changing environment. At the same time, the space is a real issue, especially in Europe, right? The land cost is expensive, and it's important to be able to use the space that you already have available, because finding more space is becoming more and more challenging. And at the same time, there is less tolerance for any errors in the sortation process. Customers require a same-day delivery very often, and they require the order to be fulfilled properly, so there is no room for any mistakes in the process or for any missorts, which happens regularly whenever you are sticking to manual operation. And there is a common assumption that the problem is just the manpower cost. The problem is maybe the hardware itself. The thing is that the actual problem is not the people problem. The problem is on the architecture side, right? So in order to really design the flow of operation that will match the current needs in today's world, you cannot think about just adding things to an existing infrastructure. What you need to do is to redesign the overall flow, overall process, and that's what we are trying to do. So with the system, whenever we start to sort in 3 dimensions, there are very clear and tangible benefits, right? So first of all, the footprint of the system can be much smaller. In many installations, we see that the space that we have consumed is 50% or less of what the operation used to be. We can deploy much faster because it's not really a fixed automation. There are just parts of the system that are fixed and can be easily installed and dismantled as well. So the installation time is shortened. The system is very flexible since it's based on mobile robots. It's a distributed kind of system. You can always scale and adjust to the throughput of the moment, let's say, right? You can have a system designed for business as usual. You can add robots during the peak. And you don't have to worry about conveyors anymore if you don't need them. Now, how does the typical system look like? It's just an example here of a very simple layout. It's called an I2 layout, meaning that it's in the shape of a letter I with 2 induction stations on the north and south. So the overall process always starts with the induction. The induction itself is usually manual, but can be easily automated through even a conveyor or a robotic arm. The way it works, the operator, after the picking process, for example, the goods are delivered to the induction station. The operator needs to scan the barcode of the item, place it on the robot, and then the robot follows on the grid to the final destination. The robots are always working in the safe area. These robots can run at a speed of 3.2 meters per second, and we want them to be really fast. We want them to be to deliver the goods to the destination as fast as possible. So that's why we have designed it in the way that the humans are not entering the space during the operation. So once the goods are delivered to this to the racking system, then the operator on the other hand side can be informed by an LED indicator that the order is ready to be retrieved. And the racking itself can be designed specifically for the application. As you see on the screen here, it's actually an example where we sort directly into bags, but we can sort into many sortation or many different sortation units. It can be a bag, it can be a tote, it can be a carton box. We also very often sort directly into chutes where they can be taken out from and packed later. Each system is also equipped with a charging station. Robots are autonomously docking to the charging station. It takes around 40 minutes to charge the battery, and after that the robot can run for around 7 to 8 hours. We have 3 types of robots. The main difference here is the top module of the robot and the size of it. So our smallest robot that you'll be able to see on our booth, we have it here, is 450 by 350 millimeters. We have the middle module, 550 by 400, and 650 by 500 is the biggest one. Typically, we see in our applications that for B2C order consolidation, usually the smallest robot is totally sufficient. For parcel sortation, last mile sortation, we typically use the bigger robot, or whenever we are talking about packed goods. The maximum payload is up to 24 kilograms. It depends on the lifting height. The higher we have to go with the module, the payload decreases. The maximum lifting height is 2.4 meters. As I mentioned, the robots run at the speed of more than 3 meters per second. And they are all powered by Li-ion batteries with autonomous docking. Okay. Typical processes that we cover, they vary depending on the facility type we are operating in, right? So the most common applications for fulfillment centers, for example, would be B2C order consolidation, where we typically sort into multi-level chutes and we replace a pre-sort and manual put-to-light system. We could also do outbound carrier sortation. We can do B2B store fulfillment. We can do click and collect. Any type of that operation can be handled by the robot. For distribution centers, we can manage returns. For sort centers and delivery hubs, we can do mid-mile and last-mile sortation, where we typically would sort into mailbags or delivery bags. Okay. And I'd like to show you 2 examples, 2 live operations that we have deployed last year. This operation is based in Turkey. It's a B2C order consolidation where we sort 5.7 thousand items every hour into almost 1,700 orders. For that purpose, we have built a system with 3 modules. Each module has 35 robots in it. And in total, what we have is 105 robots running through a free shift operation. So the benefit here was clearly visible on the manpower needed for the operation. The benefits were visible both on the picking side and the sortation side. Previously, the customer needed around 51 operators per shift in order to run this operation, and he needed much more space. Using those robots, he decreased the required personnel to 21, which is a saving of 30 FTEs per shift, and consumed half of the space. The sortation window or the window in which we open the order and we close the order is around 30 minutes, and the picking process is adjusted to that. And here's a quick video showing. I hope you don't hear the sound, because it's just the warehouse noise, which we all like, of course. But that's how it looks like. We are now looking at a single module from the perspective of the operator. The operator is inducting on the robots. We have all those five-level racking systems where we put our goods into. We consolidate those orders. On the other side, we have the packing. On the other side of the rack, we have the packing tables located. And that's where the operators retrieve the orders and place them into either a box or a poly bag, apply a shipping label so it can be moved to the outbound area. Okay. So that's the, let's say, fulfillment center example. Now, let me show you the sort center example. It's a last mile sortation located in Belgium, in Liège, actually. Here, we were requested to design a system that will be able to sort 5,000 parcels an hour into 2,000 unique destinations. And those destinations represent lockers. So we are sorting as per the PUDO points in this specific case. The challenge here was the relatively restricted area for this operation. The customer actually confirmed that we were the only supplier that managed to fit the system of that size into this existing facility, and also work around all the other restrictions, like a lot of pillars in the building, and the, let's say, relatively difficult layout of that building. So thanks to that, they didn't have a need to move to another facility, which, as I mentioned before, is a great benefit also for the customer. On the productivity side, the labor productivity has also been improved significantly. It's a 2-shift operation, which requires only 16 operators to handle. Previously, it was 44 operators per shift. So again, the savings are very significant, very tangible, and that really translates well into the return on investment. And here we are using 155 robots in a single module. You can see the fleet of robots working here. That's quite amazing, actually, to see this bunch of robots working in a harmonious way. And as I mentioned, we are sorting into the delivery box. So we are using this specifically designed for this operation chute that brings the parcels directly to the delivery box. Now, when it comes to the technology that stands behind our solution, let's say we have 3 core parts of it. Number one, I already mentioned several times. So this is this vertical ability that is implemented into our robots. So the fact that we have the lifting mechanism, that translates very well to saving the space in the warehouse. Then the other core element of our technology is actually on the software side. So what we are using is something we call swarm intelligence. It's an algorithm that has been developed actually decades ago already. And what it does, it mimics the way bees or ants operate in nature to achieve their higher goals as a group. So we have applied a very similar logic to the way the robots navigate, and the purpose is just to always optimize the path of the robot, just make it as quick as possible. And yes, make it extremely efficient. On the other side, the infrastructure, the architecture of the system is very flexible. I'm just distracted a little bit by what's happening here. But yeah, the architecture of the system is very flexible, and the good thing about it is that you can easily add robots to it, change the layout, and just adjust it to the changing environment, changing needs in your operation. Right, and the system is distributed, meaning there is no single point of failure, as opposed to traditional ways of sortation based on conveyors. Whenever one motor fails, basically you have to shut down the full system, right? In our case, if for some reason one of the robots has a malfunction, this fault is isolated, right? So you just have to take the robot out of the system. The rest of the robots, the rest of the fleet can still operate. At the same time, we have this self-balancing workloads. We can do the dynamic allocation to destinations, and the robots will also react to it instantly. As mentioned, you can easily increase the sorting capacity, so you can add robots whenever they are needed. The expansion doesn't really lead to any downtime or a significant downtime. Either you add additional modules to the system that are totally separate from each other, or you can just add the layout and at the final stage just connect the new layout, the new piece of layout to the existing one. So the downtime is really minimized, and the maintenance part is extremely straightforward. We have a lot of teams, customer teams that have been trained, not even engineers that have been able to handle those robots. And also we have a predictive mechanism that informs every customer about the coming maintenance plan. Right, and well, if you remember from the beginning of this presentation, I have highlighted all the risks we have identified on the market. Number one was the reliance on the manual workforce. You see that through a system like this, it's a relatively low-hanging fruit. It's an easy type of automation that can be easily automated, and you can have significant benefits and savings on the workforce front. It can be installed very quickly in a matter of weeks, depending on the system size. It can be customized and adjusted exactly to your facility. It can be easily scaled up or scaled down whenever needed. The maintenance is simplified, and the overall integration to the IT infrastructure is also very straightforward based on the API. So let me finish with the statement that, well, the question was never how do we add more hardware. The real question is how do we redesign the flow, and that's our philosophy, that's our approach, that's what we are trying to do, yeah, hopefully we'll see more of those robots running in modern facilities, modern warehouses of today. That's it from my side. Thank you very much. It's been a great pleasure to be here. I encourage you to visit us at our booth, which is C66. And if you have any questions, I'm happy to answer. Thank you very much.